So cube root functions for domain and range are going to be a lot easier for us to do. I've created a table of values over here, but this isn't the only ones that I want. Okay, we're going to be graphing y equals the cubed root of x. Okay, and we can do 0, 1, and 8, and 27, that's fine, but I also want to include a few other values. I want to include -1, -8, and -27 as well. So if I substitute 0 here, the cube root of 0 is 0, because 0 times 0 times 0 is 0. So I put a point at 0, 0. Substitute 1, the cube root of 1 is 1. So at 1, 1, we have a point. Substitute 8, the cube root of 8 is 2. So 1, 2, 3, 4, 5, 6, 7, 8. Let me move this guy over here. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. And then the cube root of 27 is 3, but I don't have enough space to put that on the graph. Now here's why I wanted the negatives. Okay, if I substitute -1, I can do the cube root of -1. It is defined. The cube root of -1 is -1, because -1 times -1 is +1 times another -1 is -1. And so we have a point right there at -1, -1. The cube root of -8 is -2. So over here down 2. And the cube root of -27 is -3, but I don't have space for that on my graph. Now when you connect these points here, don't draw straight lines in between these three. It's going to be a nice curve. And it continues up forever and a day. That way, and then, man, that's a nice curve right there. Okay, and this is the general shape of the cube root function. Okay, and you need to memorize this. And just like with the square root, we'll go ahead and we'll call this our anchor point. And note, from the anchor point, you go over 1, right 1, up 1, right 8, up 2. But you also go left 1, down 1, and left 8, down 2. Now let's think about the domain and range. Remember, domain is how far left are we going to how far right are we going. Well, notice we never stop going to the left. There is no kind of starting point. This arrow points forever and a day in this general direction. And so that's going from -infinity all the way up. Well, it never stops going right either. +infinity. Similarly with the range, okay, how far down to how far up? Well, this graph never stops going down. Okay, so it goes down from -infinity, and it goes all the way up, and it never stops going up. And so we have a +infinity there. To help you remember anything on the left-hand side for infinities are going to be negative. Anything on the right-hand side are going to be positive. And if you ever deal with an infinity, it's never going to be an or equal to. It's only just a less than. All right, so now let's start doing our shifts. The first one I'd like to do is a vertical translation here. So we're going to look at y equals the cube root of x, and let's just say plus 3. Why not? Well, we are adding on the outside. And remember, it's just like the square root, it's just like a parabola. If you are adding on the outside, that's a vertical translation, it's a vertical shift. The anchor point is going to move up 1, 2, 3 units. And then recall, to get your other points for a cube root function, you go over 1, up 1. You go over 8, up 2. You go left 1, down 1. And you go left 8, down 2. And then you can draw your nice graph. Okay. Now think about the domain and range. And this is the really nice thing about cube roots. Well, we're still going from all the way left to all the way right. And so domain goes from -infinity to +infinity. But notice, now when we shift up, we're still going all the way down. And we're still going all the way up. So the vertical shift doesn't really affect the range in this case. Okay, the range is still negative infinity, less than y, less than positive infinity. Another vertical translation, let's do y equals negative 2 plus the cubed root of x. Notice it's a negative 2 on the outside. That is like subtracting 2. So the anchor point, which would have started at 0, 0, gets shifted down 2 units. And then we go over 1, up 1, over 8, up 2, down, or excuse me, left 1, down 1, left 8, down 2. And we go ahead and we plot our points here, or excuse me, not our points, we draw our graph. Again, domain and range remain unchanged. Okay, we're still going all the way left, we're still going all the way right, we're still going all the way down, we're still going all the way up. And so our domain is still negative infinity to positive infinity, and our range is still negative infinity to positive infinity. So for a horizontal translation, what that will look like is y equals the cube root of x plus 1. We are adding on the inside, that is a shift to the left 1 unit. And then from our anchor point, we go up, right 1, up 1, right 8, up 2, then left 1, down 1, left 8, down 2, but that's not going to be on my graph, so I don't plot that point. And so this is what we're looking like. Now the nice thing about horizontal translations, or just cube roots in general, domain and range remain unchanged. We're still going from negative infinity to positive infinity, all the way left to all the way right. And then for range, still going all the way down to all the way up. Positive infinity. So one more horizontal translation. Let's look at y equals x minus 3 to the 1/3 power. Well, remember, the 1/3 power is the same as the cubed root function. So this is the cubed root of x minus 3. And so because of the minus 3 on the inside, the anchor point gets shifted 1, 2, 3 units to the right. Then we go up, right 1, up 1. I can't go right 8, up 2 because I don't have enough space. But I can go left 1, down 1. And then left 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2. And the domain and the range remain unchanged. We continue going to the left forever, to the right forever, so that's negative infinity to infinity. And then we continue going down forever, up forever, and so that's negative infinity to infinity for the range as well. So we're only going to do one with a horizontal and a vertical translation, and then we're going to be doing the rest in class. So what we're going to be doing is we're going to be looking at y equals, let's say the square root in this case, of x minus 2 plus 1. Now first of all, I notice I'm no longer dealing with the cube root. It's now the square root. Okay, so I need to remember that my shape looks like this. I also notice that we have a minus 2 on the inside, so that's shift right 2 units, plus 1 on the outside, so that is shift up 1 unit. So again, minus 2 on the inside, 1, 2 to the right, up 1 because of the plus 1. And that's where our anchor point goes. Now we have to remember for square roots, we're going over 1, up 1, over 4, up 2. We would go over 9, up 3, but we don't have enough room. And so we're looking like that. Now with square root, both the domain and the range are affected in this case because we have both a horizontal and a vertical translation. So the domain, remember, it's left to right. Well, we're starting, since we shifted 2 units to the right, it starts at 2. It never stops going to the right, and so that's infinity. For the range, well, since we shifted up 1 unit, the bottommost point is 1, and then it never stops going up to infinity. And we're going to be doing more difficult ones in class. So I'll see you tomorrow.